Welcome back to the reaction zone. In today's lesson, we're going to look at how to solve the problem on the board making use of Boyle's law. And the question is as follows. A 500 milliliter of a sample of oxygen was collected over water at 23 degrees Celsius and 760 millimeter mercury. What volume will dry oxygen occupy at 23 degrees Celsius and 760 millimeter mercury? The vapor pressure of water at 23 degrees Celsius is 21.2 millimeter mercury. To solve this particular question, the first thing to do is to list out the information from the question. The volume of oxygen and water vapor is equal to 500 milliliters. The pressure of oxygen and water vapor is equal to 760 millimeter mercury. Let's not forget that we are told that this volume of oxygen was collected over water at 23 degrees Celsius and 760 millimeter mercury. So 760 millimeter mercury here is the pressure of oxygen and water vapor because it was collected over water. And this volume here is the volume of oxygen and water vapor, which is 500 milliliters. Now, we have this information. Also, the question tells us that the vapor pressure of water is 21.2 millimeter mercury. The question is asking us to find the volume of dry oxygen. For us to get the volume of dry oxygen, we need to first of all get the pressure of the dry gas. In other words, we must get the pressure of dry oxygen before we can proceed to find the volume of dry oxygen. And to get the pressure of dry oxygen, we would subtract the vapor pressure of water from the pressure of oxygen and water vapor. So, pressure of dry oxygen is equal to pressure of oxygen and water vapor minus vapor pressure of water. This will be 760 minus 21.2, which will give us 739 millimeter mercury. Now we have obtained the pressure of dry oxygen. We can now calculate the volume of dry oxygen using Boyle's law. Recall that according to Boyle's law, P1 V1 is equal to P2 V2, where P1 is the initial pressure, V1 is the initial volume, P2 is the final pressure, V2 is the final volume. Because we want to find the volume of dry oxygen, the initial value of pressure, P1, will not be 760 millimeter mercury. Instead, it will be the pressure of dry oxygen. So the pressure of dry oxygen will be our initial pressure. The volume of oxygen and water vapor will be our initial volume. The final pressure is going to be 760 millimeter mercury, and the final volume is the volume of dry oxygen that we want to find. So, putting these parameters into the question means that our P1 is going to become 739 multiplied by V1, which is 500, which is equal to this 760 here as our P2 times V2. Some may ask, how do we know that this question involves the use of Boyle's law, considering the fact that we are giving temperature here to 23 degrees Celsius and temperature here as well to 23 degrees Celsius? Yes, we have the value of temperature, but the value of temperature is constant. So, V2 will be equal to 739 times 500 over 760, and this is going to give us a value of 486 milliliters. So it therefore means that the volume of dry oxygen will be equal to 486 milliliters. Thank you for viewing, and see you in the next one.